we know how to use power rule to take the derivative of a power function. And now we will learn how to use product rule to take the derivative of a product. If a function is itself the product of two functions, then we have to use product rule to find the derivative of that function. To remind ourselves, given a function y is f of x multiplied by g of x, where f of x is the first function and the g of x is the second function, the derivative of that, the product rule says that its derivative will be the first function multiplied by derivative of the second function plus the derivative of the first function multiplied by the second function itself. In other words, to use the product rule, we will multiply the first function by the derivative of the second function, then add the derivative of the first function times the second function to that result. Let's do an example where the function is the product of two power functions. The two functions in this problem are x squared and 6x raised to the power of 3. It doesn't matter which one we choose for f of x and which one we choose for g of x, since the product rule just has adding f of x multiplied by g prime of x and f prime of x multiplied by g of x. We will get the correct answer either way as long as we stay consistent. Now let us choose f of x as x squared and g of x as 6x raised to the power of 3. And then list out these two functions along with their derivatives. So the derivative of f of x, which we can write as f prime of x, using product rule is the same as 2x raised to the power of 1. The derivative of g of x, written as g prime of x, is the same as 6 multiplied by 3 is 18x raised to the power of 2. I want you to refer to the video in which I made how to use the product rule to find the derivative of functions. I will put them in the description. Once we got these all listed out, we can plug them directly into the product rule formula, which states that the derivative of y prime, is the first function, which is in this case f of x squared, multiplied by the second function. The derivative of the second function in this case is 18x raised to the power of 2. We add to the derivative of the first function, which is in this case 2x, multiplied by the second function itself, which is 6x raised to the power of 3. Now this is the same as simplifying further, 18x raised to the power of 4 plus 12x raised to the power of 4. Since these are like terms, this will give us 30x raised to the power of 4.